Hey everybody, this is Ray Harvey with Access Jitsu. Thanks for joining us on our basic video about building tables. In this video we're going to discuss what is a table and some of the terminology involved with tables. We're also going to discuss how to decide what to put in which table in your database. We'll also discuss data types, column naming, default values, and nulls. There is a follow-up to this video, part 2, and in that video we'll discuss keys and indexes. So thanks for joining us again, and stick around. So Microsoft Access is a relational database that is built to run on a workstation or a laptop. Now there are lots of other relational databases out there. You may have heard of some or all of them. Some are designed to run on workstations like Access, others are designed to run on servers, and others yet on mainframes. But they all serve the same purpose, that is to store information about some real-world situation. And the way that we do that in a database is we store data in tables, usually more than one table. So the basic building block of a database is a table. Now, tables are a set of unordered rows and columns that describe something. Now tables look a lot like grids like we have here. We have rows and columns of data. A row describes a thing and columns describe something about the thing. Grids, of course, resemble spreadsheets that you've probably worked with in either Microsoft Access or Google Docs. And then, of course, we have a table view here. If you're trying to decide how to arrange the data in your database, try to limit yourself to describing a single thing in a single table. Decide on a purpose for a table. My patient table is going to describe static information about a person, such as name, date of birth, gender, and race. So other information you might want to store about a patient would be their address and phone number. Contact information, right? A doctor's office needs to get a hold of their patient. Address and phone number are data elements that can change over time, right? People move, people get different cell phones and drop their home phones and whatnot. And whether or not you need to store that in a patient data table would be determined by the needs of your customer. Do they need the history? Do they need to know 2 years ago this person's address was such and such versus now, or do they just need to know what their address is today? If they just need to know what their address is today, then in a static table like a patient data table, I would say yes, include it. If they need the history, I would suggest probably moving that off to another table. We'll discuss that in just a minute. Some other things that a doctor's office might want to store about a patient would be like things like height, weight, blood pressure, pulse. Again, these are elements that are going to change frequently, right? A person's height is going to stay the same, except for a child. Children grow. But weight fluctuates weekly, daily. Blood pressure fluctuates weekly. Pulse, those things I would not put in a patient data table. Those are items that I think would go more into an office visit or an evaluation table. Okay, so those are some things we can think about when we're trying to decide what to put in what table. So I just mentioned the word a second ago, normalization. We're trying to decide how to reduce the amount of redundant data or storing the same data in multiple places at the same time. And I mentioned the address as an example. Okay, so take a look at this. We have Susie Q here, and she's moved. She's had 3 different addresses here over a period of time. If we were to put her address in the same table with the rest of the patient data, look at what happens over here on the left side. As she moves, we store the same data on each of these address rows for the purpose of storing these other address values. Those 4 values right there are the same on all 3 of these rows. So I think that if your doctor's office or your patient, your customer needs to know the history of a person's address, I think I would move the address off to another table and leave the more static data here in the patient data table. So there's always exceptions to rules, right? And audit data, I think, is an exception to this rule. Audit data is information that describes for research purposes, so you can know what's going on in your database, perhaps maybe who created a row, when they created it, who modified a row, when they modified it, maybe even what device they used, or if it's something, you got a database that's being used across the internet, their IP address, things of that nature, maybe the operating system, all kinds of stuff you can store to know more about what's going on in your database, especially if you have some security issues to deal with. So in a patient data table, we might have a date timestamp column on the right side over there describing when a person either created this row in the database or modified the row. We might even have a user ID further out to the right describing who did it. So let's talk about the parts of a table. The columns in your table describe some attribute or descriptive element about the thing you're storing in your database. So each row then is a collection of columns that describes a thing in your database. In this case, we have a row describing Susie Q, right? Her patient ID is 4, last name is Q, first name Susie, date of birth is 1948. So data types. We need to decide what type of data is going to be stored in each column. Databases are very particular about what you put in each column. You have to decide what is going to be in each column. And by that I mean, for instance, our patient ID column. This is going to be a unique numeric value that describes uniquely one of your patients. So we're going to define it as a number. Last name, for instance, would be a text column, right? First name the same, middle initial. Date of birth, however, is going to be a date time column. I've got another video coming up shortly that will describe in a lot more detail the different types of data types that we can use on Microsoft Access. Column names. Each column has to have a unique name within a table. Okay, you can reuse column names across tables, but within a single table, each column name needs to be unique. Now I have to go on a little bit of a rant here. Microsoft Access will allow you to put spaces in your column names, but I would ask you or suggest to you that you not do that. It's just going to make some of the syntax view in the future a little bit more difficult. Whenever you have a space in your column names, anywhere in your SQL or your Visual Basic, your VBA, you're going to have to put brackets around that name in order to work with it. I would suggest instead getting rid of the spaces and using camel casing, okay, when you need to have more than one word in a column name. Just capitalize each word and squish them together. It works great, it looks good, and it's much easier for you to be typing in your SQL and your VBA. So default values, most of your columns are going to need to have default values unless you're going to allow nulls. So default values for numbers, they might be a 0. There might be some other value that makes more sense to be a default number for a column. It's just going to depend on what the column is. Usually default for text is going to be a 0-length string or a space maybe. True false value, default values usually are false, but you can change it if you want to. Dates, sometimes it depends on the date column. It might be today's date, for instance, as your default value, or perhaps a null. Null, what is null? A null is an unknown value. It's not equal to any value. It's not equal to spaces. It's not equal to zeros. It's unknown. So you'll often find dates that haven't been filled in Access, they will be nulls. So on your text columns, there's a setting, a property, allow 0-length string. If you set that to yes, allow 0-length string, then you will not get nulls in your text column. Okay? If you set a default value, you will not have nulls in your column. However, empty, unrequired date times, they will yield a null. And I will tell you, so often I find null values in date time columns in databases. Okay, so we're going to cut this video right here and save keys and indexes for part 2 of this 2-part series. Thanks for joining us on this video. I hope you got something out of it, and we will see you next time.